All right, guys, so let's keep working with our sequences and series here. We're going to talk about now a little different type of situation where a sequence is just an ordered list of terms. A series is when you add up the first n terms in a sequence. So you see this little image here where we're adding 1 plus 2 plus 3 plus 4 all the way up to 100. And you see it ends up being a bunch of pairs of 101. So they kind of pair the 1 with the 100, the 2 with the 99. And in this type of sequence, if it's an arithmetic pattern where there's a common difference in terms, you can always pair the terms up and get this common sum. And that will actually lead us to a formula in finding the sum of the first n terms. So let's get into it and maybe do a little review and then kind of tie in the new concept as well. Okay, so in an effort to get into better shape, you decide to start doing push-ups. Let's say you start by doing 10 push-ups on day 1, and then you plan to add 5 push-ups each day. Okay, so let's list the number of push-ups you will do on each of the first 8 days. So they tell us straight out we're doing 10 push-ups on day 1, and then we're going to be adding 5 more. So on day 2, we'll do 15, then 20, then 25, then 30, then 35, 7th day 40, 8th day 45. Okay, and then maybe that would continue depending how strong you are athletic. So let's take a look at this now. What type of sequence did we just form? Okay, so if we look at the terms, we were adding 5 push-ups each day. It's a constant increase, a constant difference, so that makes this an arithmetic sequence. Okay, arithmetic sequence because we have that common difference. And then so how many would we end up doing on the 20th day? Okay, so to find a specific term, given its location, okay, the 20th term, we're going to need an explicit formula. Okay, so the explicit formula for arithmetic, as we've seen, this is still the old stuff, is always a1 plus d times n minus 1. Okay, so for this specific problem, the first term was 10, and we were adding 5, okay, n minus 1 times. If we want to distribute that 5 and kind of combine some like terms and then simplify the formula, we could write it as 10 plus 5n minus 5, which could also be combining the terms written as 5n plus 5. So that would be the explicit formula, okay, to find the amount done on any given day. So then when we want to find the 20th day, I would just simply plug in 20 for n. So 5 times 20 plus 5 will give us our answer, 100 plus 5. So you would, on that 20th day, you would do 105 push-ups. Okay, so that's nothing new. That's finding a term of a sequence. Okay, part D now, this is a little bit different. How many total push-ups, okay, total, in the first 20 days, meaning the 10 you did on day 1, plus the 15 on day 2, plus the 20 on day 3, plus the 25 on day 4, plus all the way out to on the 20th day, we said we did 105. I want to figure out what that sum is. Okay, so it might not be crazy difficult to list all 20 terms and add them up. But, you know, keep in mind I could ask, you could need to find the sum of the first 400 terms. Okay, it's just not something that you want to do the long way, if you don't have to. Okay, so let's see if we can figure out a way to get that set up and maybe use some patterns and a formula here and see if we can answer this question. Previous question now. Down here we're doing the push-ups, right? When we said on the first 20 days, you know, what is going to be the total number of push-ups we did. So now that we know that form started with 10, right, and then we added 5 each day. All right, so let's go back to that we're going to use, right, I believe. So if we think about this, okay, instead of, like I said, instead of having to list all the terms and add them all up, let's kind of dig into what was going on and kind of tie into that slide that I had showed at the very beginning with the pairs of 101s basically. And let's use that same example actually. Let's say we were asked to find the sum of the first 100 integers. Okay, and the story, the legend is that there was this mathematician in Gauss when he was a kid, I guess in school, he got in trouble and the teachers were like, you know, you need to sit down and find the sum of the first 100 integers. And until you do that, you can't do anything. So he was able to come up with the answer very quickly, and everyone was just astounded. They're like, how'd you figure that out? So that's kind of a story. I don't know if it's true, but anyways, what the problem boils down to, again, is finding the sum, 1 plus 2 plus 3, all the way up to 97, 98, 99, and 100, right? Let me tweak those a little bit. I want things to line up a little better. Let me just write 98, 99, and 100, and we'll see why in just a second. Okay, but again, all those numbers are in there. Every single term from 1 to 100, every single integer, okay, meaning whole number, is in there. So the trick is this: if you think about, if you start lining up, or pairing up, I should say, the first term plus the last term. Okay, 1 plus 100 is 101. Okay, 2 plus the 99 is 101. Okay, 3 plus the 98 is, again, 101. So we have all of these different amounts of 101s, and the trick is how many, or not the trick, but how many 101s do we have? So if you have 100 numbers and you're kind of pairing them up, you would have 50 pairs to be the full 100 numbers. Okay, so we would actually have 50 101s. Okay, and by adding those up, and by multiplying that, that would get us the sum of the first 100 integers. Okay, and 50 times 101 is going to be 5,050. Okay, so the formula, kind of see really what's going on. The 50 right here, that's just going to be, if you had a set of 100 terms and you're pairing them up, I divided the 100 by 2, right, so each one could have a pair. So that first term will actually just be however many terms there are divided by 2. Okay, for our example, it was 100 divided by 2. So the formula will be whatever n is, right? We might not always have 100 terms, but it's going to be n over 2, and then the sum of each pair, okay, is basically going to be equal to whatever the first term plus the last term is. So the first term, a1, plus the last term, an. Okay, the 1 plus 100. That's going to be equal to the second term plus the second to last term, 2 plus 99, and so on. So that's going to be our formula. That's going to get us the sum of the first n terms of an arithmetic sequence. Okay, so let's just get the formula summarized one more time, and then kind of show there isn't a second version of it, but to find the sum of the first n terms, it will always be n over 2 times a1 plus a sub n. Okay, and there's one alternative version here, because again, sometimes you might not know that last term. You might not know the nth term. I might just give you the first couple terms and say, all right, what's the sum of the first 50 terms? But you only know the first 3. Okay, so one option would be to find a sub n using formulas from before, but there's an alternate approach we can take. If you recall, we know that a sub n, the explicit formula for the nth term, is a1 plus d times n minus 1. Okay, so the alternate version just says, take this and replace it with the a sub 1, replace it with this basically. So it could be the s sub n equals n over 2 times a1 plus, now instead of a n here, I'm going to write this entire formula, a1 plus d times n minus 1. Okay, and again, make sure we're making that connection. The a sub n is really just equivalent to this. Okay, so just doing a little substitution. Now with this alternate version here, we don't need to know the nth term. All we really need to know is the first term. If you kind of look at what's in this formula here, we just need to know the first term and the common difference, and then how many terms there are. Okay, so that's an option. Okay, and I just want to kind of go through an example showing you how to maybe use each of these. Okay, I'm going to use this sum formula right here and answer the question. So the sequence itself, I'm getting this, was so the sequence was 10, 15, 20, and so on. and it went out to the 20th term we had was 105, right? That was a sub 20. We found that in a previous problem, part of that problem. And our question is, what is the sum of these terms? 10 plus 15 plus 20, dot, 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 if we had all the way out to 105. Okay, so the formula says the sum of the first, in this case there were 20 terms. Okay, let me just write the formula down here. The sum of the first n terms is always n over 2 times a1 plus an. Okay, we know all of those values. We know n, okay, we have 20 terms, 20 over 2. Okay, we knew the first term in the sequence was 10, and we knew the 20th term we had found to be 105. So sometimes you just have to go and find that to use in this formula, and you can definitely do that. And now we're just going to simplify. The 20 over 2 is 10. In the parentheses, 10 plus 105 is 115. And 10 times 115, we'll just throw a 0 on the end. So on those first 20 days, you would have done a total of 1,150 push-ups. Okay, let's set up another example. Okay, here's another sequence. Okay, and let's just find some things, some old things, some new things. Okay, so a sub 2, s sub 2, a sub 50, and s sub 50. So let's think about this. So a sub 2, right? That's just saying find the second term. A sub 2 is just 6. Okay, it's just the second term. S sub 2 now just means the sum, just to get used to this notation, the sum of the first two terms. Okay, now to do that, do we really need to use a fancy, crazy formula? Not really. I mean, we could, but the sum of the first two terms are 4 plus 6. That is just 10, okay? You could use the formula. It's probably better not to. We'll save the formula for the part D there. Okay, but anyways, a sub 50, okay, again, this means the 50th term in the list, right? So that's when we would use the explicit formula. Okay, a sub 50 is going to equal, this is going back to the sequence formula, it's the first term plus, in this example, the common difference is 2, and it will always be times n minus 1. Okay, so 4 plus 2 times 49. 2 times 49, of course, is 98. We have to do that first, multiplication. So what that's telling me is the 50th term, right, by the 50th term in position in order would be 102. Okay, that's just finding a term like we did previously. Now this new one, s sub 50, we want to add up the first 50 terms. Okay, that's when we use the new formula, n over 2. Okay, because basically, again, think about if there was 50 terms, there would be 25 pairs, so that's what we're finding there. And each pair would add up to the first term plus the last term. The first term was 4, the last term was 102. Okay, so 50 over 2 is 25. The 4 plus 102 is 106. And 25 times 106 will get us a sum of 2,650. Okay, so that would be the sum of the first 50 terms. All right, let's take a look at one last example. Let's say we have another sequence here, 3, then 7, then 11, and we want to find s sub 50, the sum of the first 50 terms. Okay, and let's do this with that alternative version. So again, we know the sum of the first 50 terms. Okay, so the idea is the main formula is always going to be n over 2. Let me just write the formula in terms of general n over 2 times a1 plus an, right? In this case, we can put the n's in. N was 50. Okay, so we would need to be doing 50 over 2. There had to be a marker there. 50 over 2. And let's go ahead and just substitute. We know a1. We know the first term of this sequence is 3. Okay, but the problem becomes we don't know that 50th term, right? And we could find it. You know, we could use the explicit formula and all that stuff. Here's where I might want to just show you using the alternate version. Remember the alternate version. Okay, the first version is this. It's a1 plus an. But when you don't know that other term, we kind of showed that by just plugging in the explicit formula for that, right? A sub n is really just equivalent to another a1 plus d times n minus 1. So it's just a matter if you want to find that first or just do it in the formula, because we don't really need to know a sub 50 necessarily. It's part of the formula, but we can just go ahead and get the sum using this alternative version right here. Okay, so let's do it. Let's see what we got. N over 2, 50 terms. So 50 over 2. A1 is 3 plus another 3 plus this sequence common difference of pattern was 4, and then the n minus 1 is 50 minus 1. Okay, and we can just do this calculation here, simplify this expression to get the sum without needing to necessarily find that 50th term. Okay, so the 50 over 2 is 25. We have 3 plus 3, we have 6 plus 4 times 49. Okay, which is 25 times 6 plus, the 4 times 49 should be 196. Okay, so just doing the parentheses, 25 times 202 is going to give us our final sum of 5,050. Okay, so that was a way, again, just using the alternative version. You're free to kind of use whatever you want, but just remember that version is really just plugging in the explicit formula for the a sub n in case you don't know it and you might not really need it. Okay, so that's how you find the sum. This only, again, works for arithmetic sequences and finding the sum. There's a little different process for geometric. All right, there we go.